Hello, once again, folks. Welcome to Thinking Out Loud. This is number 17. So, yeah, this is really cool. Today, as you may know, we're going to have James Urquhart and Clemens as well. So, we're going to be the three of us chatting about cloud events and async KPI and, event-driven architectures and even the worldwide flow, which we might need James to explain what is this concept if you haven't heard about it. Really cool concept, that way. But before we start, let me just do the usual ceremony. So I always say, like, don't be shy during the conversation, and it's true. So we can see that we have folks from Dallas and Guadalajara in Mexico. So yeah, welcome everyone, and don't don't hesitate to ask questions. Let's make it as collaborative as possible. We can't be all of us in the stream; that would be unmanageable, right? But we can all be chatting and via text, via chat, right? And having conversation. So yeah, don't hesitate to participate. Also, if you need enable closed captions, if you need or prefer closed captions, head over to our YouTube channel, and this is youtube.com/asyncKPI, and there you should have an option to enable closed captions there. It's not available in Twitch and other platforms, so sorry for that. We'll try to do better next time, next season, actually. And yeah, I usually continue saying that please follow us on Async KPI Spec, because you'll see lots of cool stuff, or I think that you'll see lots of cool stuff that could be interesting for you. But today, I can't continue without saying something that guy in the chat, Lucas Gornitsky, told me, I kill you if you don't mention it. And he's Polish, and I fear him. So yeah, I'll have to mention. So we're organizing the Async KPI conference 2022. This year is going to be in person and virtual. It's going to happen in November this year. Days are still to be defined, and you can find more information in conference.asyncKPI.com. But a specific thing that I want to highlight here is we don't have the days yet, exact days. We don't have the exact location yet, and that is all because we're organizing this with the community. So we're surveying the community, and we're telling the community to participate and say, like, hey, where do you prefer that we organize this this conference, right? So we have like a list of locations, and yeah. So head over to the website, and there you'll see a survey, and yeah, so you can collaborate there as well. And hey, Michael from Ottawa. So yeah, and that's it from now. Let me introduce our guests today. So please welcome James Urquhart and Clemens Fasters. Hey, folks, good afternoon and good morning.
Hello. Morning. Or afternoon for us.
Actually, evening almost. In Germany, it's almost evening. In Spain, it's still morning, maybe.
Yeah, it's 4 o'clock, which means in Spain that's about lunchtime, right?
Yeah, I was gonna
About
say,
lunchtime, exactly.
Exactly.
I was in the desert, so
You're about to lay down for a nap, if I remember correctly.
So yeah, and so yeah, thanks a lot for joining. You might, guess you might want to introduce yourself and explain a little bit better what you do, who you are, and so on.
Who starts?
Who goes first?
James starts.
All right. My name's James Urquhart. Spent a long time writing about cloud computing. So some of you may know me from a blog I did called The Wisdom of Clouds years ago. But I've always been somebody who's sort of very analytical about technical trends, architectural trends. And so currently I work for VMware. I'm helping out with the VMware Tanzu application platform, which is a new development, multi-cloud development platform that we are offering. And I've been studying and working very closely with our customers, developers, and operators, and sort of understanding the patterns of use there. And then finally, I wrote a little thing. So there we go. I wrote a little thing for O'Reilly called Flow Architectures, the Future of Streaming and Event-Driven Integration. Yeah, there you go. See,
That's somewhere too.
he has a signed copy somewhere. But we'll talk a lot more about the subject matter of the book, but really it's focusing on what I think is going to be a dramatic change to the way data moves online as things like async API and cloud events and other things become more increasingly adopted as standards, or whatever it may be in the future. There's no guarantees yet, but so that's me.
Okay. Clemens Fastas. I am the lead architect for all the messaging services in the Azure platform. So we have numerous services, Event Grid, Service Bus, Event Hubs, and the Relay that are kind of in our direct team. And then we also have numerous other kind of services that are messaging related in the Azure platform, IoT Hub, SignalR, the SignalR service, and Web Hub Sub, as it's called, for non.NET platforms, Notification Hub. So there's a fairly broad portfolio of messaging services, which we liaison with, and they use the base that we built under the covers. And architect means that I'm also I'm dealing with technical strategy. Part of technical strategy is also standardization, and in that capacity, I've been working on horizontal standards for several years. I've been working in the AMQP technical committee. I'm the co-chair there. I've been quarterbacking our efforts in the MQTT technical committee for 5.0, and I'm a member directly now in that MQTTC. I am co-architect, I would say, of CNCF Cloud Events. We don't have kind of formal roles in that effort, but I'll just claim to be one of the architects of it. And I've also been involved in various vertical standards. For instance, I've been working with the OPC Foundation. That's a standardization effort for the manufacturing industry, automation industry, who are standardizing across 800 vendors, I think, who make industrial machinery. And they have a communication standard that is kind of like think of it as more USB, Bluetooth kind of model, but that kind of allows for industrial machinery to click together. And that is also obviously emitting events. And so the PubSub binding for how can these industrial machinery, how can that go and create eventing exhaust into IT systems? That's a standard called OPC UA PubSub. And I've been the architect for it in that effort. So fairly broad portfolio of involvement in standardization. And so cloud events is currently the most active effort that I'm involved in.
That's really cool and extensive. We all knew that you were you were really well known in the standards space, specifically for event-driven architectures. So I can't only say thanks for all your work in AMQP, MQTT, and cloud events. You've done a really great job. So yeah, thanks a lot for that. Thanks a lot both for all the job you're doing, and thanks also for all the things that you did wrong in the past. So we can learn from them. No, just kidding. I'm just.
Oh no, that's a valid. Brilliant, Alex.
I mean,
You're
I'm kidding.
welcome.
I'm partially kidding in the sense that I don't know what you did wrong in the past, but,
So
but
that's
yeah,
important. It is important though. So for
it
instance,
is.
Doug Davis and I, so Doug is effectively the chair of the CNCF Cloud Events group. He used to work for IBM forever, and then he just recently came and joined us at Microsoft, which we were very honored by, and still are. And Doug and we started being involved in this whole standardization story with web services, with the original XML SOAP web services stuff. So we've seen a lot of iterations of the same things. So we've seen SOAP and Cloud Events. If you squint, it's not so far away, and we are making kind of frequent references to it in the sense of the things that we don't want to do. And so it's being aware of the things that you did, and then trying to not to do the same thing that was bad in the past is helpful. But we've also seen things like UDDI, and I think the general and WSDL. And so the general belief is that, for instance, UDDI was a thing that was completely before its time, before anybody cared, but not a terrible idea. UDDI, for the younger people, is the Universal Discovery and Directory interface, I think. And that was an XML web service interface for doing catalogs of web services. So allowing you to find by criteria a web service endpoint, and then go and discover effectively its WSDL, its interface definition, and then be able to communicate with it. And that's in a completely programmatic fashion. And that's something that would be fantastic if we had that today, but we don't, because it was embedded in this giant hairball of super complicated things, which then ultimately was sunk by W security. So it's good. These are mistakes from the past that we're well aware of, and they are actually benefiting the Cloud Events effort, for instance.
And by the way, what I'll argue, and is a big part of the argument behind the book, is like our needs, the need of data to essentially flow to where it's valuable, is driving a lot of invention that helps to overcome the first of all, it decides standards in reality, and then secondly, it will figure out how do you overcome a bad standard or a bad attempt at a standard. And so you could argue that the replacement for UDDI that we have today is Google, right? And stack trace and a number of services that people can use to discover services and how to use them, right? And in the book, I believe that there will be a formal discovery need for event-driven, and we'll talk about flow a little bit more. But I clearly admit that it could just end up remaining that, right? It could just end up remaining that human beings search websites and they find the descriptions of what they need, they implement what they want, and then the need for discovery goes away, right? The need for programmatic discovery.
But that for the robots.
Anyway, that's an interesting example for sure, because we did learn a lot from that. We learned a lot from SOAP for sure. We learned a lot from the initial definitions of object-oriented architecture and the attempt to sort of lock down definitions of spaces and domains, and how that just wasn't very resilient and caused us more problems than it helped to solve. And so we've, I think, to me, again, it goes towards the what reduces toil and reduces risk, reduces both toil and risk. If you don't do both, then you can't really develop with it. And so I think we are getting to a point with EDA now, with event-driven architectures now, that we are at the next phase of looking at how do we reduce toil for certain things we do with events, and how do we reduce the risk involved, not only with security and things like that, but the risk that the choices we make will burn us in the future. And so, which brings us to the standards and async API and things like that.
Yeah. Speaking of past mistakes, I and we at Async API, we have a few things to say. And actually, we're working towards now version 3, trying to solve all the mistakes that we did in version 2 and previous versions. And yeah, like this has been a pain for us. Like, we've been committing a lot of mistakes in the past, trying to, like, first of all, and the biggest one I will say is treating or coming up with async API from OpenAPI. Like I just duplicated OpenAPI, and it was like, okay, let's just change some things and get put post. No, who needs that? Just publish subscribe, and then at some point it's like there was an inherent mistake there that was almost hidden. That was that the perspective of the operations, the publish and subscribe, right? Like, what does publish and subscribe means? Does it mean that the application is publishing or subscribing to a channel topic or something like that, or a queue? No, it means that a potential client can subscribe to the one that you are providing in your application, which in API terms makes total sense. It is like, here's the endpoint, you can request and you'll get a response. But in terms of event-driven architectures, some of them, especially broker-based architectures, it is highly confusing. It is kind of backwards, right? And with, for instance, with WebSockets, client-server model in WebSockets also works well. It's like, yeah, it has more to do with the topology, right? Like client and server, that more than the, let's say, the protocol itself. So you could be using WebSockets with a broker, and you will have the same problem. So yeah, so when we've been always trying to communicate this in social networks as well, like, hey, we're trying to come up with a better solution for this. We need to reorganize the whole spec, and that's what we're doing for version 3. We're still in the process. So help us shape this, right? And I remember a comment from Clemens on Twitter saying, like, the API concept on the, so that question goes for you, Clemens. So it's like, you said something like the API concept on async API is toxic or something like that. I think you said. So and I was a little bit like, what does he mean? Like, I think I know what you mean, but yeah, let's just give you the opportunity to explain what you meant there, and I'll continue later.
So there's the first version of async API that I looked at was clearly trying to model an API, meaning a set of operations with requests and responses over asynchronous channels. And that is something that people do, but it's not doing the infrastructure and also what people do with those infrastructures justice. And it's also a very peer-to-peer focused view on things. And what happens with eventing systems, but also with general messaging, is that flows are far more complicated. So effectively, if you're limiting the definition of a contract to a client talking to a party, and then make that kind of a correlated request response scenario, that is something that satisfies some use cases, but it doesn't allow you to kind of create a view of the greater contract that exists. There's a standard that is unfortunately an ITU standard, which means it's illegible. And it's ITU 1, I think it's ITU 120 or 121 or something, or 140. I forgot, because I looked once and then never looked again. But they do something very interesting. What they have done is they've taken effectively an activity diagram, as you would know it from UML, where you have kind of actors having swim lanes, and then kind of the messages that are being passed within those swim lanes. And they've managed to go and formalize that as contracts. So they have contract definitions that say, in a flow, I have X amount of actors, and those actors collaborate on getting an outcome. And that's actually closer to the reality of how messaging systems are being used. You have messaging systems are trying to establish a decoupled, temporally decoupled, and also coming from a transactional perspective, decoupled set of workflows that are where control passes through message flows. Not talking about eventing for the moment, but really talking about core messaging for a second. So you order something from a website. When you're ordering something from the website, that's already kind of, you're being handed over, the transactions already being handed over through queues on the back side sometimes. But then once you press the order button, your payment is being settled, your order is being transferred to one or two more fulfillment centers. The fulfillment centers then need to go and collect the stuff that you ordered, need to go and package them. They need to go and pass information onto a service that's initiating shipments. The shipment is then being confirmed. Then you need to go and create the package, label it. So there's all of these activities, and all of them are kind of initiated through some form of messaging. And having a full view, like a complete view of that whole interaction, that entire flow, I think is useful as a contract definition. And then out of that entire contract definition, you get effectively a slice out of that, kind of the messages are being passed between two swim lanes, and they become effectively an interface that is then implementable by one of those actors. Every actor that kind of has a swim lane has ins and outs, and those are the interesting things to implement. That's just for core messaging workflow, which means it's not just one party talking to another party, but it's a more complex thing where a message causes a message out to another system, then another message may come in from yet another system. And so having that totality represented in a contract, I think would be super useful. And that's something that we don't have as a formal standard at all, except for this one oldish and really written in the 90s and being the style of the 90s ITU standard, which has probably been implemented somewhere in telco, but really not in the internet. For eventing, the story is such that events are being raised as statements of fact and not as jobs, which means you have a state change that happens in the system, and the system has no expectation of anything being done with that state change. So let's say you are in a CRM system. In that CRM system, a new lead has been created. A salesperson has a contact with a person. They can basically go and log in and say, here's this new person, and I did something with them, and logs that into the system. You may now go and write an extension, and that extension will now go and send them an information package by mail. That's something that the person who entered the information is not intending, but that's someone who extends the system, does that kind of with that information has been volunteered. So that's another way of that's where the PubSub thing comes in, right? You're publishing information, and then you volunteering that information to third parties, and the third parties kind of attached to those things. That again is not an API in the sense of you making a command, but you're basically offering information up, and then you have consumers which go and grab that data on the other side. But you may have one of those subscribers, you may have N of those subscribers, and it's a feature that the publishers don't know who's subscribing, right? And that they can't count them, and that they can't give them instructions. It's a feature of that decoupling is a feature. And also, in terms of temporal decoupling, being able to put a job into a queue, or being able to put an event into a queue, and for that event then to be sitting there potentially for a minute, 10 minutes, an hour, depending on what the load on the back end is, that's fine. And if you have an API lens, meaning you do a call, and that call is something you await or just block on, then the characteristics, these RPC-like characteristics, assume that the calling thread will still be alive when that answer comes back, and that's often not true. It is often I issue this activity, and then it takes a while for that to complete, and then the activity will go and come back. It will be coming back. That information will be come back effectively on a callback that is not on the same thread that issued the original call. So there's a lot of differences between RPC style characteristics and method call characteristics, and these event flow and command flow characteristics that are done with asynchronous messaging, which are more typical and which then leverage the capabilities of those platforms.
So as you were speaking, you were mentioning this whole landscape or big picture of how the activities are happening, right? Like what's happening in the big picture, right?
Mm-hmm.
And then as a side effect of defining that, then you could get slices, as you mentioned, right? Slices of this information, and you could get even point-to-point interactions, right? As a side effect of that. Now my question is, could we build something the other way around? So we offer people to document only the slices, and then we group them together and create a full picture map.
The contract,
and that's for both.
Yeah.
Let me just answer that in the handoff.
Yeah, no worries.
Certainly, the contract definition that you will use to go and generate code for any individual party, which plays a role in this, is going to be scoped to the few messages and channels that they use. So yes, I think the definition that they care about will be very similar to the kind of scope that async API might have with a set of channels. I just believe that the greater picture is interesting. Also, these are unidirectional flows, and that's important, right? It's not a call, it's a message flow, and that's a very very important differentiation. It's not an operation that's being executed; it's a message flow that's being accepted or emitted.
It is important to note that the act of subscribing is a call and response action, right? The act of saying, I want to subscribe to this message flow. So it always starts with a call response activity in the initiation of the connection. And I think that's important to note, because I do believe that there will be the pub subpart of this is going to absolutely be a very familiar API format that people are going to understand very well and know how to use. But then everything so I'll say that that's one thing. And then the second thing I kind of want to point out, which is really, really, I think critical if you're going to work in a complex system space, which increasingly these things are absolutely like one critical form of definition of an adaptive system. But if you're going to work in these spaces, the only way that I've seen it successfully done at scale at all is that you need a picture of what's going on across the system. You need to understand the flows. You need to understand the feedback loops. You need to understand who the good actors are, who the bad actors are, right? But you can only take action at the individual agent. You can only change what other agents that agent is connected to, or change the rule set that the agent is implementing, right? That's the only way that you can affect the behavior of the system. And so from that perspective, I think from what you're saying makes a lot of sense, in the sense that really the only thing a programmer is going to do to change the flow of the system is either insert another thing in the middle of the flow to change routing or to filter out messages or whatever it is, or they're going to change the agents to how they, what they subscribe to and what they do with the information they get, or what they decide to publish. And so from that perspective, I think you're very right about that aspect. And so when I look at this, I really haven't thought a lot about this in terms of contracts, and it's probably really good that Clemens talks to that stuff. For me, when I really think about in terms of reducing the cost of integration, which is really kind of where my focus has been, then it does come down to a picture like what you talked about a little bit, Fran, right? Which is like, I'm really only going to connect to individual streams. I may take multiple streams together and do something with those multiple streams, but really the flow part of it is I'm going to initiate a connection, and then I'm going to check to see if the data that I get over that connection is something I can interpret and understand, maybe, whatever. And then I'm going to do whatever processing it is against that data if there are no problems there. And, but I do agree that if I can't visualize how the system is flowing to the scope that I care about and can do something about, if I can't visualize that, then I'm going to have a absolute really high risk mess on my hands in very, very short order. So this is one of the reasons why in Flow, I published it a year ago, a little over a year ago. So a little over 8 years, or 8.5 years or something from now, we'll have this standard set that we're all using, like the mainstream will be using. But one of the big reasons for it is because the idea of how we communicate the information we want to communicate about what's actually happening with the flow, that is something that's a very, very complicated thing. It may end up being super simple in that it's just human or simple programmatic relationships to say, yes, I process that event, okay, and that's enough. Mm-hmm. Or it may need to be within an enterprise much more sophisticated. There might need to be a graph aware view. And I've seen this week a big explosion in talk about GraphQL and things related to that. And so there may be some aspect of that comes into play that's necessary to make this work in an enterprise at scale. And I'm not saying GraphQL specifically, let me be clear, but some way of programmatically being able to understand what's happening with the flow, get signals when we need to be responsive, but also to be able to query and ask the system what's happening here.
This holistic perspective is important for complex systems, not only because once the flow ends, right, messages are photons, and once the data is no longer in motion, it gets stored somewhere, but it's still the same data. Mm-hmm. Meaning that there is a holistic view you need that goes beyond just the messaging part. So, for instance, let's talk about data schemas for a second. We go and move data around that is schematized. Structured data is the most common that we move. And the way how the structured data is formed is because of business shapes, business requirements, business data that you're flowing. May that be, business may also be something that's purely technical, like what comes out of a sensor or whatever. That data then gets transposed into databases and gets stored in databases, but the structure remains largely the same. Or it lands in a data lake where it then gets stored as is and then gets transformed, imported in some other form. Which means the schema for schematized data, may that be just constraining schema in JSON or in XML, or may that be the schema necessary for serialization with Avro, protobuf, etc., that needs to be put somewhere. That schema is valuable for messaging, but it's also valuable for storage, meaning being able to go in and deal with data in batches. It's also important for stream analytics, meaning you transport data with an event stream engine. You have a stream analytics engine at the edge of it. The stream analytics engine attaches to the stream. It goes and reads the payloads. It needs to go and reason about the payloads. It needs to provide a development experience against those payloads, which means it needs to go and deserialize. All of that is kind of schema driven, which means the schema story needs to be one that works across all those platforms. One of the async API observations is because of the open API heritage, the model is upside down because it starts with the server and then it starts with the endpoint basically and then sorts under everything underneath. With this messaging story, it's actually exactly opposite. The most shared piece that everybody needs to go and deal with is data put in an envelope, moved in an envelope, taken out of the envelope, and now being handled somewhere else. That is the most important thing. In async APIs, it stands. It's kind of the thing at the leaf of the definition, right? Because it's just treated as and that's not a criticism per se on async API, but it comes out of the heritage of where it comes from, right? Open API treats a message as just a response to a call. The operation is the thing, the parameters for the operation, and return values for the operation. That's the central aspect. But really, for message flows, for eventing flows, the most important thing is the data, and that's shared across all these participants of all this. Then you have the envelope. And the envelope basically defines for all participants in a flow, what is this thing? And we must assume that the data that's contained in here will be end-to-end encrypted, maybe using some form of encoding that the intermediaries don't care about. And the intermediaries will be smart to not reason about the payload because of encryption or because of encoding. And because if you're building PaaS services as we do, you never want to touch the payload, because that's runaway, unconstrained compute in doubt that you can monetize on top of. So for PaaS services is something that touching the payload is a no-go, because it's just a deep thing for compute cost. So we don't want to do that. We need to have the message definition so we can go and create rules around dispatching about how do we route messages, and that's why we have a common definition for what a cloud event is, and we also need to have metadata, a catalog of those events, because that catalog will then drive developer experiences, which means you're not talking about the concrete instance of the event, but you talk about a candidate list of events that may come out of a pipe, so that you can go and do a drop-down list in a tool and say, okay, which of these 5 events do you want to handle? Okay, this one. All right, go and generate the code that's required for it and the dispatch logic for it. So that's the order is schema, and then the message definition, and then those message definitions may then be grouped together and form effectively this allowed set and the available set of messages that flow through a particular channel. And then that model also needs to allow for aggregation, meaning you have 3 sources, maybe 3 different versions of sources, which are 3 different devices which are sending data, but they send this through a common telemetry path, which then ends up in an analytics platform, which has to go and deal with all these 3 signal streams at the same time, because we need multiplexing, because channels are expensive, etc. So and if you look at the constructs we're currently working on in cloud events, they actually mirror that. We have a schema registry, we have a message catalog, and so we have these base pieces that we believe are useful and valuable for just this basic capability of annotating a channel with the messages that may go in and that might come out.
So that's really cool, and I love that you're saying this, because it maps very well with what we have planned so far for version 3. So something that we realize is precisely the importance of messages or events and the flows, right, and the pipes or channels, or call it whatever you want. So those are first class citizens now in the spec. All of them, right? And but we still have something that we're discussing is, so we move out of this application perspective or service perspective that we have right now, like because so far what people are asking us is, we want to generate code as much as possible for my application, so I need to understand what my application or what this application is doing or is going to do or could potentially do, right? So is it going to publish a message into this channel? Is it going to subscribe to this channel and receive messages that are flowing there? If so, what are the messages in these channels? So or how they look like, so I can get this, I can generate code, I can generate documentation. So
Mhm.
I completely get your vision of the, like, the holistic vision of the organization. Like, that's and I agree, like, this is, to me, that is the best way to unify how messaging works in organization or in the world, in the case of worldwide flow, which you'll have let's not forget. So you can mention about something about it. um, and But then on the day-to-day, right, job, developers are more interested in something they can deal with and they can touch, right? And those um, globally or company level defined rules are slow per se for development, because it's the way usually companies work. Like, responsibility is divided by teams or by squads or whatever you want to call it. And then each of these, especially in the case of microservices, which is, and not just micro but service oriented architectures, um, these teams have the responsibility of an area of the business, right? And so they want to create applications or services that are going to publish and subscribe to different channels, and they're going to be leading with cross-cutting concerns, which are the messages, right? So the messages probably are going to flow to another team responsibility and another one, right? So
Mhm.
it's a cross-cutting concern, right? So it is, to some degree, is like APIs. When you call APIs from another team is exposing for you to use, so it, in this sense, is more or less
Mhm.
similar. So when I proposed back in New Relic, and also talking to some friends, like, when I proposed, like, why don't we make it like a unified thing for the whole company? And if you want to add something, a new message, a new channel, something like that, we go to a central repository if we want, or central place, and everything is managed there. And so you cannot do weird stuff. Everything is there, and there will be a review process, so architects can review it, so it makes sense, right? And everything like that. But the problem with this that they were exposing is this is freaking slow, right? Because this is freaking slow because that's the argument, and I experienced that in the past. Like, this is
Mhm.
usually freaking slow because you have many teams, and the bigger the company, the slower it can become, because you have multiple teams at the same time going to a central place, and so that central place that is reviewing all the applications for submitting new messages or channels, um, it's getting overwhelmed, right?
Yeah,
It's
that's
getting overwhelmed because of the amount of requests, right? So they were looking for something more from their side, from their team side, from for the comfort of their team, right? And so they can expose that. And then, as a side effect, they were like, we want to standardize this in the company. Let's make sure we follow guidelines. But some companies care about those guidelines and some companies don't care at all, right? Because they don't need, or they don't think they need to standardize this message driven communication, right? So that is why, like, my concern here is that, are we forgetting about the developers daily
no.
job here?
So what we're doing with the sub working group that's currently dealing with schemas discovery, and the catalog effectively. Um, what we're so we have decided what we're not going to do, and we have decided what we're going to do. So we have decided that we will not tackle contract yet, because
Mhm.
we think that's a huge work on its own, and we don't think we want to go and bunch that into together with what we do. And contract meaning, what is the relationship of the application to messages, and how do messages correlate with each other, and do they correlate at all? So that's an area where async API is actually doing work, and that's an area where we have, but we're actually drawing the line. As said, we have been looking at this ITU spec, and said, interesting. There's lots to cover. There's lots of value in there, but we need to go and do the basics first.
Yeah.
what we are aiming for. So we have drafts of these 3 specs in the repo right now. So there's schema registry, which is already implemented by Epicurio and Event Hubs in Azure. There is the discovery spec, and there's the message catalog spec. We're currently trying to get them all kind of integrated into a single effort. That single effort will have 2 shapes. One is it's going to have a document, which means you will be able to express everything that's expressible in these 3 things in a single doc. Which means if you start as a developer, you'll be able to specify the schema and the shape of your messages and your endpoint in a single place. But then you can also break them apart in 3 different areas, in 3 different documents that can be federated. And then for each of these document types, we're going to have an API where you can go and manage them effectively. They're smart document stores, if you will, mm-hmm. so that you can host them as a central repository if you want to. But the tool should always be the tools that go with these specs should always be able to work on a doc. And that's kind of the local experience. That's the local developer just getting started and just want to do their local thing. But that should also work with that central repository, because there are companies mm-hmm. where there is this giant central repository where the management needs to happen, where for legal reasons there needs to be governance around particular fields of messages because they need to be labeled with certain labels mm-hmm. and all that stuff. That needs to happen. But the goal is that we're building for the areas of schema and message definitions, and then discovering these endpoints where those messages flow into and out of. That's the scope of it. That we can define a model which is both document based and, in the simplest case, in a single doc, and also can go and spread across 3 hyperscale stores that can go and provide schemas for all the services that need schemas, can provide mm-hmm. message definitions for everything. It can go and flow a message, and then can provide endpoint discovery, basically within the scope of an enterprise if you want to.
Mm-hmm. So I was talking more about the human factor here, right? Not so much about the technology factor.
Yeah, it's the document. So that's why I'm saying the document, having a docky, you can go and check in with your repo, which mm-hmm. is the foundation for the code that you generate, is just as important as having an API. And that's the first iteration that we did with these services, or with those definitions, is that were purely API based. You had to have a running thing to make those things usable. And we're now saying, no, the start for a message catalog is really, you have message definition that sit in a GitHub repo. And then you may have a smarter thing which can do validations, et cetera, with a dedicated endpoint. But the start is have a single developer be able to go and define all those things on their local box as a start. So it's really driven by that thought around that workflow.
Okay, I see what you mean.
So, and since we just have a few minutes left, I wanted to pop out my big observation about sort of mm-hmm. where the overlap between interfaces and protocol exists, which I think is pertinent to what we're just talking about, which is the more I look at it, the more it feels like it's the bindings, it's the code generation for the interface calls that enable you to use MQTT or AMQP or WebSockets or whatever mm-hmm. it is, and it's the data schema mapping, I guess, for lack of a better term, for both the metadata and the payload, that is critical then to make sure that what is placed on the wire in each of those wire protocols is interpretable by in a consistent way on the other end. And it feels mm-hmm. to me like, where I've been more and more excited about the idea of async API and cloud events together being sort of that flow protocol set is because I am seeing movement in sort of the understanding of that aspect of things, right? There's still not a clear use of cloud events in async, but I know that's being worked on. I know that there's strong action there. And there's still a binding function in an async API, at least in version 2, that when I read through it, reads like, oh, we're going to take care of the data mapping as well as just sort of the interface mapping piece of things. And so that's my one observation here is if there was a known binding for cloud events via async API, my gut tells me that that's going to go a hell of a long way towards being the worldwide flow API and protocol set of the future. Yeah. And again, I could be wrong. I'm just saying, based on the feedback I'm seeing from numerous parties that are involved in all of this, that really feels like it would make a lot of people very comfortable very quickly.
Will you mind expanding on the worldwide flow concept? Maybe
sure.
So people understand.
The idea behind flow architectures is pretty straightforward. I was thinking for a long time about the movement of data towards value. And, I have this mental image that I use, and it's helpful sometimes, it's hurtful sometimes. But, when you're a kid, you took a bucket of water, you'd run up the beach somewhere, you'd dump the bucket of water, and you'd watch all that water figure out a way to get back to the lake or ocean or whatever you're talking about, right? To me, data is constantly, because of human beings and human needs and greed and all that stuff, right? Because human beings are directing the flow of data, data is constantly seeking value. It's constantly seeking a place where it can add to, in some way, benefit some group of people or person somewhere. And so where we are right now is the the API economy, kind of the REST world, kind of exploded the idea of sort of commands and requests being made, sort of that synchronous instant conversation becoming something that sort of exploded open to all kinds of new ways of doing business. And I was thinking very much about event-driven and going, well, streams, wow, what can we do with that? And I had breakfast with Tim O'Reilly one day, and I said, Tim asked me what I was currently thinking about and working on. And I said, this is the thing that I'm obsessed with right now, is what would happen if it was really cheap to be able to both publish data that other people find valuable and consume data from others that is valuable in the form of events. And so you get the state change information. And very quickly, with very little analysis, I came to the conclusion that, oh my God, that's going to open the floodgates for real-time data exchange across organization boundaries. I mean, it is going to, you already see it in places like Walmart. They're already starting to dictate event stream requirements, as I understand it, the articles that I've read, right, where vendors have to sort of signal current inventory state changes in order for Walmart to be able to clearly express on their website that we have X in stock. Well, that's because we don't have it in stock, but our vendors have it in stock. So and we're seeing it with the FAA. This is the one that Solace, the one of the event streaming companies or event routing companies. Solace points out the FAA has a massive customer base that are just consuming event streams, basically using, again, their proprietary protocol or standard interface. It's not standard that other people are using, but it's already happening, and it's already incredibly valuable, and it's already changed the game in a huge way. I mean, if you've used one of those apps where you point up at the sky and see what airplane it is and what its flight log is, there's a huge amount of that FAA data being used there. Real quickly, the worldwide flow is simply then the idea of when all of this becomes really standard and programmers don't even have to do work really to say, hey, they just configure something to say connect to this stream and start consuming data using this protocol, using this data schema. Then at that point in time, all activity will become interconnected. And so like HTTP connected the world's information and created the World Wide Web. My belief is that these flow protocols are going to connect the world's activity and create the worldwide flow.
So you actually put words in the name to concept that we had. I think we all had in mind in a long time ago, maybe, or we had discussions in a long
Yeah, I'm
time
not the
ago.
first. I'm not the first.
Yeah, like we had, and I was like, when I was reading the book, I was like, hell yeah, like someone put a name and it's finally talking about it like it's real. Like actually, you start the book by telling the story like in a utopian world, maybe like
Mhm.
in a few years from now. So and I was like, yes, so now we can work backwards and see what we have to do to get there, right? So that is actually super cool. And just to wrap up a little bit because we're already over time, but we started late, so let's stay
Yeah, fair
well
enough.
a few more minutes. So I think to get to that point, and correct me if I'm mistaken, I think async KPI and cloud events have to collaborate closer. That is a must because we're covering different areas of that scenario, right? So they need to be integrated somehow. And in the next versions of async KPI, like I said, we're kind of decoupling from this request response or this tree and leaves that Clemens was mentioning before with the messages and the servers on top and so on. So that will be good enough to at least start the new reorganization of concepts here.
Mhm.
And next step for me, I will say, at least for me, or I would love this to be done is in async KPI, you should be able to define an envelope, or more specifically, you should be able to define that your envelope is a cloud event, right? If you want to call it an envelope, or if you want to, I don't know, but you should be able to say like, hey, this is not just one message, any
Mhm.
kind of message. This is a cloud event message, right? And this is the cloud event definition. It's here. Go and get it and interpret it and do whatever you want to do with this, right? And something that I recently discovered by going to the cloud events repo is that you guys are working on a subscription API and a discovery API.
Correct.
Um, the discovery API got my attention because we were kind of doing some similar effort on async API or thinking about it, but not doing it yet for version 3, but it was too much, right? So I was thinking that maybe that discovery API, this discovery, in short, like this discovery API is returning a list of services, right?
Mhm.
A list of services that are exposing certain events and so on, right?
Mhm.
So, and those services are defined using a specific format that you created on Cloud Events. And I was instantly saying, this is what we're doing on async KPI. We're defining the same information or almost the same information.
Mhm.
Like, cool Cloud Events be returning an array of async KPI documents in this case, or subset, or at least a subset of async API documents for that. So everything works together and it's like completely integrated, right? So you want to use cloud events, you can use it in async API. If you want to use async API in the discovery API, if you're going to use the discovery API, you get async API in that list, and then you get the async API tools instantly ready to deal with those things, right? So that is my understanding so far of
Mhm.
how things could be moving forward, and from here, this is like a statement from my side that we should be collaborating
Yeah,
more.
I
Actually,
agree.
not more. We should be collaborating because we're not collaborating at all yet.
We have in cloud events some as exhaust, so to speak, of that definition work. There is some stuff that is kind of in no man's land, if you will. Um, for instance, cloud events is focused on events, which means unidirectional flows of facts and kind of constrained with the constraints of the 7 attributes that we have, and we have intentionally stayed away from correlation or anything that kind of drives us into general messaging, because there it gets complicated. But now, speaking as the AMQP-TC chair for a second,
Let me wear the other hat.
right? From the AMQP side, there is a need for having these contract definitions which look almost exactly alike, right? We need to have the same kind of schema registry stuff for the payloads. We also need to have definitions and templates for what messages look like. But they're intended for a different purpose. They're more fully kind of request-response messaging. There's a notion of correlation of certain kinds. There might be session stuff involved. So that is, for me, it makes no sense for that to be a very different dialect of how you go and define those things. They're just defining a different kind of message. One is the cloud event, and it's a broader set. And then you have a narrower story, which kind of around AMQP message brokers, which have queues and are even more opinionated. And that's something that Async API covers too.
Mm-hmm.
So when I think of message catalog, there is a message catalog schema type sort of that is cloud events, but then there's also a message catalog type that is an MQP type, and then there's an MQTT type potentially. So and those things are not exactly at home in the cloud events effort, but I don't think they need to be different. I don't think we need to have a completely new structure, a new, a different kind of API, just because the base schema of the envelope is different. Yeah. So that's an area of collaboration where it might be that the cloud events owns the shape of the cloud event definitions and the cloud event schema, and then we'll have an AMQP collab. Which kind of defines what that looks like. And then maybe there's an MQTT collab, which goes and defines what the other things look like. That's something we can go and take a look at. I'm certainly, for me, and speaking for Microsoft, we're totally open in where to house those things, especially because Async API is a Linux Foundation project now.
Totally makes sense to me. Sounds like
right.
A deal here. So we just need to explore further, man.
I think it's awesome, and really, the complexities. I think one of the things that this conversation really hopefully exposes to people who may not have been aware is it's not having a pub sub API and having a message and payload format that we all kind of agree, right? Basics that we're all kind of cool with that. It's that detail level of how do you make sure that these things behave well in a variety of really unusual use cases that makes this hard, and where the conversations really have to go. Where does the interface end? Where does the protocol begin? Where does the wider protocol end and the data protocol begin? Those are the hard questions that we're all kind of beating our head around here. And so it's really fun watching. I should participate more, but unfortunately my day job isn't as directly related to this stuff as I would like it to be at times. And so
you already participated, man.
No, this is what I did instead, right? Is write the book, and I'm happy. I'm on Twitter as we all are, and happy to answer questions for folks if they come across them when they're reading the book as well. And I hope everybody gets a chance to read it. So
great.
So thanks a lot, folks, for joining today. I have the feeling that we left lots of things untouched. So maybe we have to be meeting again in the future. So yeah, or maybe we have to do this regularly. Right. So yeah, me too. I will be super happy to do it. So yeah. Again, thanks a lot for joining. Thanks everyone for watching and participating in the chat. Thanks, Chris, for this ITUC 120 name, which we couldn't figure out. So yeah, thanks a lot, everyone, and yeah, see you soon. And
thank you.
Stay well.
Thanks, guys.